Hey, Big Hamsters, this is Mrs. Vandelay bringing you Blankwalle, Chapter 14, Section 5. This is called heterogeneous equilibrium, reactions involving solids and liquids. So it says conditions of a heterogeneous equilibrium. What does heterogeneous mean? What does that prefix hetero mean? It means not the same throughout. Okay, so what does that mean? That the state of matter of the products and the reactants are not identical. That's what that means. So it says the position of heterogeneous equilibrium does not depend on the amounts of pure solids or liquids present. You pretty much ignore them. If pure solids or liquids are involved in a chemical reaction, their concentrations are not included in the equilibrium expression for the reaction. Why is that? If it's a pure solid, you don't have a solution, so it's not moles of solid per liter of what? If it's a pure solid, you don't have a liter issue, all right? If it's a pure liquid, you don't have moles of a solute, it's pure liquid. So neither of them can be expressed in terms of molarity, so they can't be involved or included in the equilibrium expressions, all right? So pure liquids are not the same as solutions. I just said that, whose concentrations can change. Like I said, a solution has a solute and a solvent. A pure liquid is missing the solute, all right? So here's the example. I have carbon monoxide making carbon dioxide and carbon solid. So what is my Kc expression, all right? Well, here it is, and if you look at this, all right, I kind of scroll this down a little bit, not too well, can I? Well, anyway, here I'm trying to get the picture that's showing. Oops. I start off with some equilibrium. If you look around, I have a little bit of carbon here, and I have some carbon dioxide and carbon monoxide, right? So I have the same amount of carbon dioxide and carbon monoxide equilibrium, but what's obviously different is my carbon, all right, but that doesn't make any difference because it's products over reactants, isn't it? Okay, so notice that carbon solid doesn't even count in this, does it? Okay, yeah, don't even stick it in there. So I can't have a concentration of pure solids, so it's not part of the expression. Let's go on to the next page. Alrighty, row. Consider the following equilibrium expression. We have ammonium aqueous plus water liquid equals, or not equals, but is in equilibrium with ammonia aqueous and hydroxide aqueous. Why don't you go ahead and do problems A and B? I think you can do this. So pause this. When you're ready, come back. Okay, welcome back. Let's see how you did. Well, here's my law of mass action. I put my products, my aqueous, over my reactant. Notice water is not in there. You don't include it, okay? And so now I'm ready to come up with an expression. I'm going to take my ammonia, which is 0.02, my hydroxide, which is 0.6, divided by 0.05. And when I do the math, I get 0.24. So that's my Kc. Again, water is not even included. For problem number 13, which reaction does Kp equal Kc? So why don't you go ahead and pause this and figure it out for yourself? All right, well, how about letter A? Ignore your solids. So I have one O2 and I have two CO2s. Nope, I have to have them equal, don't I? Ignore your solids here. I have solid and solid, ignore them. So I have three gases and three gases. I think that's, oops, that's our winner right there. Let's check out letter C though while I'm at it. There we go. Solid is the only thing on the reactant side, so I have 3 and 0, so that doesn't count. That's an important thing. You can't have a 0 then as your coefficient. So we're going to see that coming down here. All right, so let's look at problem number 14. Okay, so write the expressions for K and Kp for the following processes. So I have solid phosphorus pentachloride decomposes to liquid phosphorus trichloride and chlorine gas. So that's what I have. The first thing you really do need to look at is it balanced? So go ahead and see if it's balanced or not. By golly, it is, all right? So hopefully you figured that out too. So go ahead and write down Kc, all right? Or just K is Kc, okay? Go ahead and write that down. All right, is this what you got? That's what I got. And now we need to find out what Kp is. All right, well, here's my equation. Hopefully you're getting used to that. And now what? We got to figure out what delta N is. Do these two terms count when talking about delta N? And the answer is no. So ignore this one, because they're not gases. This is not aqueous, so it doesn't count. Oops. And so the only one that counts is the chlorine gas. So when I go ahead and do this term next, I get a 1 here, because it's really 1 minus 0, which is 1. Okay, and I can just leave that term out because RT to the first is RT. How about letter B? Okay, so deep blue solid copper 2 sulfate pentahydrate is heated to drive off water vapor in the form white solid copper 2 sulfate. So here is my reaction. I thought I'd give that one for you. I even balanced it for you. So go ahead and find out what Kc and Kp is. Okie dokies, how'd you do? Well, Kc is the concentration of H2O raised to the what? Raised to the 5th. That's kind of crazy, isn't it? And then here I have Kp equals Kc times RT raised to a certain power. And what would that certain power be? Well, does my solids count? The answer is not at all. So what is my delta N? It's 5 minus 0, which is 5. So there it is. They're definitely not equal to each other. So what about calcium carbonate decomposes? Why don't you go ahead and pause this and figure that one out too. If you're stuck, what is calcium carbonate and what very stable gas can come out of calcium carbonate, and then what is left behind? Maybe that will help you. All right, is that what you ended up with? I hope so. So what's Kc? Just carbon dioxide. There's no coefficient from that, is there? So what is Kp? Well, delta N is 1 minus 0 because these two don't count. They're solids. And so again, Kp is equal to Kc times RT to the first, which is RT. Okay, and that's it. That's the end of this section. So as always, don't wait to be great. We'll see you next time. Bye-bye.